Hello and thank you for visiting the Danfoss Video Network. Today we're going to look at Danfoss's family of TU thermostatic expansion valves. The TU family of TXVs, first introduced in 1995, were first used in some of the most challenging of applications, mobile refrigeration and ice machines. Today, they're also widely used in commercial refrigerators and freezers, as well as retail display cases. Although the valve can be equipped with a variety of charges, the most common charge, the N charge, is designed to function in a temperature range from -40 degrees Fahrenheit to +50 degrees Fahrenheit. TU TXVs are available for systems ranging in capacity from 1/10 to 4.5 tons that use R134A, R404A, R507, R410A, and R22, R407C, R407A, as well as natural refrigerants such as R290 propane. The TU family is comprised of 3 types of valves. The first valve, the TUA, is designed with an interchangeable orifice, or cartridge. This means that a technician can pair an individual valve body with one of 10 orifices, permitting a single valve body to function from 1/10 to 4.5 tons, depending on refrigerant. The TUA also has a superheat spindle to permit superheat adjustment. The valve's wide range has made it particularly popular for TXV replacement. The TUB comes with a factory-installed non-replaceable orifice, meaning that its nominal capacity is fixed. Like the TUA, it does have a superheat spindle permitting superheat adjustment. This valve is popular both for replacement and among equipment manufacturers. The final valve in the TU family is the TUC. This valve has a non-replaceable orifice and a fixed superheat. This valve is typically only used by equipment manufacturers. Most technicians have found that the easiest replacement for a TUB or TUC is a TUA. Danfoss has created several kits to ensure that the technician has any TUA they might need on hand. We will discuss those later. The small but robust TU valve is made from stainless steel, giving it high strength, low heat conductivity, corrosion resistance, and a light weight. Now let's take a look at some of the individual components that make up the TU series valves. The valve design is a result of Danfoss's 75 years of innovation in TXV design. We've identified the most common power element failure points and designed them out of the valve. The capillary tube is also made out of stainless steel due to its flexibility and resistance to metal fatigue. Because we use stainless steel for its construction, the cap tube is less likely to break due to this metal's flexibility and durability, and the power element will not rust due to the stainless steel's resistance to corrosion. Danfoss laser welds the power element rather than using plasma welding. Unlike other welding processes, laser welding directs heat only to the joint and reduces metal fatigue to the diaphragm, which means the diaphragm is less likely to fail prematurely. By brazing the power element to the valve body, Danfoss has eliminated the primary point of refrigerant leaks in TXVs. Also, a brazed power element prevents outside debris from coming into contact with the diaphragm, something very likely given the dirty environment in which TXVs are typically installed and serviced. Very small particles of debris have been shown to rapidly wear through the diaphragm, greatly reducing TXV lifespan. Now let's move to the superheat spindle located on the side of the TUA and TUB valves. If adjustment is necessary, using a 5/32 Allen wrench, remove the superheat cap. Use the same wrench to adjust the superheat. Turning the spindle a full turn will produce a roughly 4-degree change in superheat. Turning the spindle clockwise will increase superheat. Turning it counterclockwise will decrease superheat. We recommend making adjustments in quarter-turn increments and waiting 15 minutes between adjustments, or until superheat stabilizes. The bimetal design of the TU's connection, which is unique to Danfoss, ensures that installation of the TU is quick and easy. These connections are manufactured by pressing together sheets of copper and stainless steel under intense pressure. The result, once brazed, is a true copper-to-copper connection that can be brazed and unbrazed, unlike copper-coated connections. Because the inside of the connection is copper, the joint is copper-to-copper. That means that just about any standard soldering or brazing material found on a typical refrigeration technician's truck could be used to make the connection. Danfoss recommends SIL-FOSS 15. One of the advantages of stainless steel's valve construction is that stainless steel conducts heat 11 times slower than copper or brass. This means that no wet wrap is required to protect the valve when brazing a connection. This helps to make installation of the TU quicker and easier than other brands of thermostatic expansion valves. It's recommended that the installer not use wet or paste flux when installing a TU, as these varieties of flux contains chloride, which corrodes stainless steel. Now let's look at a typical TUA installation. If installing a TUA, use the following method. If installing a TUB or TUC, the process is the same except you don't need to worry about installing an additional orifice. It will be pre-installed in the valve by the factory. Note that the screen or mesh on a TUA is on the orifice and can easily be cleaned or replaced simply by removing the orifice. Note that the orifice packaging canister is designed to assist in proper installation of the orifice. All the technician needs to do is seat the gasket in the indentation in the canister, insert the orifice, and press down until you feel the washer click onto the orifice. Please note that once the orifice is removed or replaced, the crush gasket should be replaced. New washers come with each orifice, and bulk packages are available for purchase. First, select the proper orifice for the application and install it in the valve. Technically, the orifice should be tightened to 19 to 22 foot-pounds. Typically, this equates to tightening the orifice until it is snug and going 1/4 turn more. Next, fit the copper piping into the valve's connections. In this case, our technician is also installing a fitting reducer to match the valve's outlet and the evaporator inlet. The copper pipe should be heated with a torch until it turns red hot. Next, move the torch to the valve connector until it begins to change colors. Then apply the soldering material with the flame pointed at the joint. As with any TXV installation, be sure to direct the torch away from the valve. Look for the soldering material to flow evenly to indicate the joint has been made. Do not attempt to build a crown or ridge over the joint, as TU connectors draw in soldering material. Attempting to build a ridge may clog the connection. Now the sensing bulb and equalization port can be installed. As this is an internally equalized system, we will only show installation of the sensing bulb. Locate a horizontal section of the suction line after the evaporator outlet and place the temperature sensing bulb between the 8 and 4 o'clock position, avoiding the 12 o'clock position. Placement should vary depending on the size of the suction line. The larger the tube, the closer to the 4 or 8 o'clock position. The smaller the tube, the closer to the 1 or 11 o'clock position. Using the patented copper strap included with the valve, tighten the bulb onto the pipe. This will create a slight indentation into the suction line, which ensures excellent heat transfer. If a horizontal placement is not possible, a vertical bulb position will also work. A vertical position should be located away from the backside of the suction tube to avoid the oil and heavy turbulence common to this area. Completely wrap the bulb and all exposed ends with insulation tape. This will ensure that the bulb is sensing the refrigerant and not any ambient temperatures. Now with the TU completely installed, perform a leak check on all connections. After ensuring that there are no leaks, you can properly charge the system to the manufacturer's requirements, making sure there is the correct amount of subcooling. Finally, let the system run for 15 minutes for stabilization before adjusting the superheat if necessary. That's it. It's as easy as 1, 2, 3. Danfoss offers 3 convenient kits of TUA valves to ensure that you always have the right valve for the job on hand. One kit has a complete set of orifices, as well as R22, R134A, and R404A valve bodies, plus a similar set of orifices and valves for flare applications. Another has only the complete set of TUA valves and orifices. The third kit comes blank, permitting you to fill the set with the valves and orifices you need most frequently on the job site. Thank you for watching our program on our TUA thermostatic expansion valve. We hope that you now know just how easy it is to install. As the leader in expansion valve technology, Danfoss will continue to explore and discover new technologies to make your job easier.